p.m. So, welcome everybody for joining our April 26th event with Dr. Spendia. It's our pleasure to invite her. Um, Let me hit the recording button. Where's the recording button? Okay, here you go. Let's get started. So, can Dr. Spendia introduce yourself?
Yeah, thank you, Helena. Thank you very much. So, super excited to be here. So it's my second time to speak at the Washington, D.C. Quantum Computing Meetup. Last time I was here was like 2 years or 3 years when I was a quantum evangelist at Quantinuum. Now I'm the technical prize director at XPRIZE for XPRIZE Quantum Applications competition. My background is in physics. I have a PhD in physics. I was in academia for 10 years, but then I worked into the quantum computing ecosystem, which I have been enjoying the last 3 years. So first of all, thank you for coming on a Saturday. I really appreciate it. So the idea here, it would be like I go over kind of like what XPRIZE is, why quantum algorithm development is actually like something that we thought an XPRIZE is worth doing. And then I give a little bit of update about the competition, right? So who's in the competition? What are people working on? To give you a little bit of flavor and hopefully get you excited when we announce the finalists at the end of this year. So in any case, XPRIZE is really all about kind of our mission is, to have an abundant future for everyone. So everyone can like live their life to the fullest and resolve the big challenges we have in our society. So really much XPRIZE is a global leader in designing and launching very large scale incentivized competitions that should push, humanity's like solve humanity's biggest challenges. And really what we're doing when we're doing that, we're really trying to like convene an ecosystem to come join us when we do this, right? Because obviously XPRIZE is a small foundation, about like 80, 90 people. And we obviously can't do that. So we need to have everyone come join us to solve these problems. So what is the origin of XPRIZE? So maybe you have heard about, in 1919, we started to build airplanes. And more or less, like at that time, there was like this competition, right? Where we kind of wanted to fly nonstop from New York City to Paris. The prize purse was $25,000. And sure enough, Charles Lindbergh won that prize, right? In his aircraft Spirit of St. Louis. So this is kind of like the first bigger incentivized competition where we know it kind of sparked kind of like, wow, we can have commercial air travel, right? We can have airplanes that bring persons from point E to point B over the ocean. We don't need a ship. It doesn't take, months to do that. And it was just really opened up something that's just like really like, helped us to become a global, and so many things changed by having aviation. In that kind of spirit, then, 30 years ago, XPRIZE launched the first prize, and that was the Ansari XPRIZE. And pretty much it was a $10 million prize purse. And the idea here was that, you build a spacecraft, you can fit in 3 people in that spacecraft, and each are like 90 kilos or something. And then you have to put it 62 miles up in the air, right? And the spacecraft comes down, and you do it again in 2 weeks. And that was kind of the idea. And pretty much during that competition, obviously the team won the $10 million. It was, we were able to do that. We kind of opened up low-cost, reusable space travel, right? So the prize kind of incentivized space travel. Now we have Virgin Galactic. They pretty much took the IPO and went further. So with like $100 million, the teams kind of invested, we are now having $1 trillion industry, right? And it also really opened up something that was previously not achievable for us to go travel into space, right? Because when XPRIZE was started, pretty much only government was able to launch something into space. Private people couldn't, right? So really the XPRIZE opened that opportunity up. And this is pretty much all it is, right? So our approach is that we kind of set audacious but achievable goals, right? To meet some of the global challenges we have that maybe be deemed impossible or kind of a moonshot. Then we tried to get the ecosystem together. We tried to crowdsource the best of the best, right, in order to work on the solution. And then we kind of show that this solution we have is actually effective and can accelerate the technology or whatever it is forward, right? So that we actually going to have this positive real world impact. And we've done it over 30 years. And we have launched 30 prizes. And here's just a set of all the different prizes. Some of them, were $2 million. Some of them were $100 million. We actually just announced a $100 million carbon prize. I will show in a picture in a bit. But we kind of like now figured out how to do this as a foundation. 30 prizes over 30 years. And we keep kind of like looking for these different areas. And we have some in education, some in health, some, in deep tech technology where the quantum prize is housed. So we are having different domains where we try to launch these prizes. And just to give you an idea here, what the numbers are over the 30 years, total prize purse was 500 plus million. About 35,000 competitors have joined us over the 30 years. We have had a lot of scientific publications and patents and trademark filings. But I think the biggest thing is that with a $500 million prize purse, we were able to invest in the competing team, the ecosystem, everyone, around investors, the entire world, over $4 billion. So it's really kind of an accelerator for the teams that solve these challenging problems to move something forward. And here, I just want to share something that we are really proud of right now, is that we just announced our carbon removal winners earlier this week. Here you see our winners. So it was a $100 million prize purse. The grand prize was kind of like you had to remove successfully or show that you can scale up to 1,000 net tons of CO2 a year, right? So initially kind of carbon removal was seen like impossible when the prize started, but now it is actually possible. It's scalable. And we have shown, these teams have shown it. And Maddie Carbon won $50 million. And then we had runner-ups that also won $50 million to $5 million. So it was a very big celebration. It just happened earlier this year in New York, earlier this week in New York. So very exciting. So now you kind of get a feeling of the XPRIZE, right? So why are we doing this? What's the whole goal? Really it is, we're trying to make the world a better place. Figure out a technology that's kind of stuck. How can we help it unstuck so that we can accelerate improvement development, right? So this now brings me to quantum computing. So first of all, what I want to talk about is, I think, I know that the audience here is diverse, and a lot of you are actually in kind of the nitty-gritty of probably solving quantum computing and quantum advantage. So, we probably working on this. Others maybe are more familiar with what you see posted and such, right, in social media and the news. But what I want to give you now is kind of the view of XPRIZE, right? Why a prize was needed for quantum applications, right? So I think what I want to do is I want to jump right into quantum advantage, more or less. I don't think I need to give you background on quantum computing overall, but pretty much what we all know about quantum computing is that, that quantum computing is a system, as a quantum computer is a system that behaves differently from classical systems, right? You have qubits. You have to think about superposition, entanglement, interference, all the cool stuff in quantum mechanics that you learn. So it's a very different way of compute, right? We are building quantum computers right now. So it's a realistic prospect to improve the noisy machines we have right now and to scale them, right? And quantum computing is starting to get a tool where we apply it to problems, right? It feels like we can actually solve things that possibly we couldn't do otherwise with a classical computer, right? So we're starting to have these aha moments and it's fundamental science where we suddenly see something a quantum computer was able to unreal that you weren't able to do with a classical computer before, maybe because we didn't look at this, but a quantum computer already makes. starting to make some improvement, right? Starting to make some moving forward for fundamental science and other applications, right? So in my opinion, quantum computers are right now the most powerful kind of compute we have, known by physical laws. Obviously, there's you can think about like making chips more energy efficient, maybe a different way of compute, right? Instead of using chips like material things, maybe we have to go to like kind of mimicking the brain more. Maybe we have to do like kind of like biocompute eventually. Who knows, right? But eventually, right now, quantum computing is kind of like the best known we can do with current known laws. And but we also are aware that quantum computers gonna have limits, right? So they are gonna be limiting, but we are just now exploring all of this. So now I want to talk about kind of quantum advantage. And that's obviously kind of like getting a little bit overloaded a term. You hear about quantum supremacy, quantum utility. I don't want to define any of this, but because that's kind of like not what my role is. But really, when we think about quantum advantage, it's kind of like the situation where a quantum computer can solve a problem that is either impossible or intractable, right? Or impractical for a classical computer, or just like in more reasonable time frame. And using feasible resources, whatever beside these resources to be. So this means that the quantum solution provides a meaningful and demonstrable improvement of what we can do with the best known classical algorithm. Well, that's already very loaded, because what's the best known classical algorithm? Because classical algorithms or classical compute is improving as we speak, right? So that's kind of a barrier that keeps moving. So we do know that the key to quantum advantage, wherever the way you want to define it, what it is, right? Algorithms are the key to that, right? And you can have the best hardware in the world, right? You can have everything set up, but you also need an algorithm, right, that solves your problem. So it's kind of like the key to eventually have quantum advantage is the quantum algorithm that you then can have meaningful, solve meaningful problems faster than on classical computers. And it's not just to have a quantum algorithm to be faster, right? It must be inherently optimized compared to the classical algorithm, right? Which is also improving, which is kind of what I already spoke to. So this is a kind of like a graph I want to show, because I really kind of like it, how it kind of like shows what we think we have to do. So you see we talk a lot about quantum speed up. You have this quantum algorithm, you have a quadratic speed up, polynomial speed up, exponential speed up, right? And typically all of that is kind of like theoretically developed, right? Like we have this mathematically, this kind of speed up, maybe defined in terms of a computer science problem. But there's more into it. You have to then, load the data. You have to do compute. A lot of stuff is hybrid. Then you maybe have to send it to the cloud. There's a lot of things that go into like computing. But what you could look at is overall kind of like the time it takes to solve the problem, right? With all of the stuff that needs to be added in order to the quantum computing, like in order to like run it on a quantum computer. And then kind of like the problem size as it scales. And then you can say like, okay, so for my problem, maybe I need a week. I want to do it in hours. I want to do it right away, real time. It could take years, right? So even that's right now applying for classical problems, right? We can maybe solve something in a couple of weeks. Very heavy, high energy physics calculations happen right now, right? If it's years, it's not useful, right? For example, when you are submitting a grant to a cluster, sometimes they're saying, okay, this person is trying to compute something. It will take a really long time in order to compute this. By the time maybe we made improvements, and it could be shorter to solve this problem if we wait a couple of months. So maybe we should give someone else the money, because that computational problem takes less time. So these kind of decisions we already make right now in classical compute. But the point here is like, we want to have a quantum speed up. So if you look at the problem, for example, a quantum computer here is just shown in like the line, right? That is kind of like linearly increasing. That's a problem you can scale on a quantum computer linearly nicely. And then you have a classical computer, which is shown in blue. As the problem size increases, eventually, right now, a smaller problem size, a classical computer actually takes way less time than a quantum computer, but eventually there's going to be this crossover point, right, where suddenly the quantum computer could potentially solve this problem better than classical, right? So we're already having applications. I think annealers are very, very kind of like pushing that. My knowledge from what I read out there is that you have this crossover point, and then when you are like a user, depending on what kind of classical compute resources you have as a user, right? You have these crossover points where you kind of like say, okay, I'm getting to a point where maybe I can try this quantum solution to a problem, and maybe I can already get some good, maybe it's like faster based on what classical compute I was using prior. So there's this crossover point where you have to decide what works for you, right? For example, quantum algorithm experts would like to make sure that this crossover point, you reduce the time and the resource, like the problem size, right? And so on. So everyone is kind of looking at this crossover point differently, but you as a user eventually have to make a decision, when is this crossover point and when I do a jump on a quantum computer instead of a classical. Obviously, there's also cost involved when you switch. But we're starting to see people that are, exploring this way and saying, okay, I'm starting to maybe see that there's a potential for me to move forward. And so I'm already like kind of like very excited about quantum computing. But they have to make a decision where this point is and how they want to move forward. Okay, so then I will talk about a little bit about proven quantum advantage. So that's kind of like where a lot of stuff right now, like heated discussions happen, right? So a lot of people say, okay, we have this massive research effort. We are having all these people working on this. We only have a handful of algorithms, right, that have been proven to offer clear quantum advantage over classical methods, right, mathematically. But it's not just that we show mathematically, like, like kind of like scaling that it out, like the classical algorithm scales like this with problem size, and the quantum algorithm scales like that with problem size. So here we go, we have a quantum advantage. But it's more than that, because a good quantum algorithm should also tell you, not just show you the speed up, right? It also should tell you about the resources required for the implementation, right? So what are the resources required for the implementations? Because then you know how near term your algorithm would be, right? You can think about for fault tolerant and quantum computing, the gate complexity, secret depth, right? You can think about the space complexity, how many qubits, ancilla qubits if you do error correction. If you work with annealers, annealing time, your scaling behavior, right? Then you can think about analog simulations and continuous variable quantum computing. Then it's more like maybe Hamiltonian evolution time and system parameters. But in any case, also maybe hybrid quantum classical compute, right? So that the iteration complexity, right? Data loading, you name it, right? So you have to kind of like a good algorithm should tell you all about these resources, whatever backend you decide to use, whatever, quantum. So if it's like in fault-tolerant quantum computer, a NISQ quantum computer, an annealer, something else, right? Photonics, whatever you want to use, right? It's your decision, but you have to kind of, your good algorithm tells you what resources you need. So obviously, on some of the applications, that's where kind of like XPRIZE comes in now, is that like algorithms have shown that it maybe requires millions of error-corrected qubits, right? If you do fault-tolerant quantum computing, and runtimes that grow, into like years in order to solve something that is actually a big enough size of a problem you want to solve. So obviously, it seems like we're learning about these things, but some big problems are really still far away, and we want to try to bring them closer. So here, I just want to give you an example. Obviously, there are many examples I could give. I just do like personally molecular simulations. I was a biophysicist by training. I built super resolution microscopes, so I do like looking at nature, especially like molecules and how they interact, especially drug development. But in any case, we are kind of right now, we can simulate small molecules pretty well. Within the classical or the exact solutions. It could be like hydrogen or beryllium hydride, but even, so 6 qubits or whatever on the systems, right? we're working with kind of like resource estimation for more complex molecules, right? So if you now look at like kind of enzymes, these are more complex molecules, and we're starting to have resource estimation for these. For example, might be like, over 2,000 logical qubits, and you may have to run for 4 days in order to solve, kind of the structure of like an enzyme. And we're trying to estimate the resources needed right now to like maybe like possibly like model these molecules and more. But right now we're kind of like more on a smaller scale, but obviously we're gonna move forward. And what I want to show here, and this is just out of a publication that was published in 2021, so it's a little bit outdated in that sense. But what I want you to pay attention here is to kind of like the space complexity. So you have on the first column, you have the years, right? So you see how over the years, over 15 years, like more and more people have worked on this. Then kind of like obviously a reference for it, but then in the third row, so for its third column, you see kind of like the algorithm innovation, right, that happened when they were trying to like solve this problem. So this is actually for, kind of like evolution in quantum chemistry simulations, so kind of sticking in this area. And then you have the space complexity and Toffoli complexity for T gates. And what you can see here is that, order of n, and then we're kind of like trying to like kind of like hover around the same thing, but kind of the complexity, the scaling is improving, right, over time. So you can see that we are making progress, right? We are kind of like improving the scaling. We need, yes, less and less and less and less resources, but it's still, for example, 2,000 error-corrected qubits, and you still have run it for 4 days, right? So it's still not really near term, but it's like getting there because we don't have 2,000 error-corrected, fault-tolerant qubits right now. So in any case, that kind of shows you where we are. So this is where now the XPRIZE Quantum Applications competition comes in. So pretty much what happens is that XPRIZE in the ecosystem, by talking to experts in quantum computing, academics, industry, government, right? And then also like kind of like people that are actually investing into the ecosystem, right? Into building quantum computers. You bring them all together, you convene them. And then there was this idea of like, could we have an XPRIZE for quantum algorithm development? Because we anticipate the hardware, right? If you look at providers' roadmaps, we anticipate hardware that should be, useful by 2030. That's what the ecosystem is telling us, right? But we need urgent action because we don't really have quantum algorithms that could use these useful machines yet, because the expectations of like some of these big problems we want to solve. So I want to like maybe also like kind of like differentiate here from what I define, what XPRIZE defines as useful for what they want to solve. So XPRIZE wants to solve the large societal challenges, right? And for that, you typically need like very sophisticated quantum computers. For someone who is doing an optimization problem, they might feel like quantum computers are already useful or become soon useful, right? So I just want to make sure that you understand that there's difference of like what you define as being useful. But for the XPRIZE quantum applications, really to tackle these real world application scenarios, and we need to have algorithms that do that. And we also see that, there's a problem with commercially kind of like geostrategic. It's kind of like benefits only a small like community possibly, but we want to make sure everyone has a benefit from it. Quantum expertise is kind of like still scarce. And there's like this hype problem, which we all kind of like know about. So anyways, so the XPRIZE is kind of like wants to come in and convene the ecosystem to see actually if we can solve something like, big problems that we would like to solve. Sustainable nitrogen fixation, right, to feed the world, or improve, speed up for drug delivery and design, right, and create more effective materials for carbon capture. These are just some ideas that we kind of like looked at or we're throwing out here. These obviously go together with the SDGs, right? The SDGs we want to like put forward. I think there are like how many SDGs are there? a number of SDGs, the Sustainable Development Goals, right? Where we kind of like want to kind of societal problems we need to like tackle. And that's not something that XPRIZE has like put forward. That's something the ecosystem has put forward. And the ecosystem has put forward that we want to use quantum computers for all of these things. So pretty much now it's up to the ecosystem to show that we actually get there, and to show that it's near term. And we hope that the XPRIZE was very well positioned to do that. Okay, so now I'm going to talk about the XPRIZE Quantum Applications competition after I kind of like give you an idea like where it falls right now in the current state of quantum algorithm development. So the XPRIZE Quantum Applications competition is pretty much collaboration between Google Quantum AI and GESTA, so Geneva Science Diplomacy Anticipators. They came together and sponsored the prize. And then together with us, XPRIZE, because we're the experts in designing and launching and executing large-scale competitions, we came together. Together with the experts, judges and advisors we have currently impaneled, the prize was developed. And together we really want to nurture the growth of an ethical and forward-looking quantum ecosystem, right? But also like advancing quantum computing with quantum advantage for real-world problems that have a big impact for our society. So initially, the Quantum Applications competition was launched a year ago, so we're 1 year into the competition. It's a 3-year competition, $5 million prize purse. And initially, we had 750 so teams interested out of 77 countries. And what the prize is kind of like looking for, because obviously quantum computing is developing, we still don't know which modality will be, kind of like setting the path forward, where we're going to be with fault tolerance, computing and such. Or we don't even know if we can develop more new algorithms, right? Have we explored everything? Is this what it is, right? We hope not. So, so the contribution types for this competition are threefold, because there's a lot of like possibilities still. There's still a lot of stuff we need to explore. So first of all, novel algorithms. So here we're really looking for a new quantum algorithm for solving the new class of problems, right? With quantum advantage. And so that could be like something that falls into Shor's algorithm, right? Not the Shor's algorithm, but something new that we haven't developed, right? But it's very difficult to develop algorithms because, again, we only have really a handful of algorithms. New applications. So you can also take an algorithm that is already developed, right? Where we know there's quantum advantage, possibly for a new application. So there's a quantum algorithm that was developed, and you show that for this specific application, you actually can get quantum advantage out of it. So that's another entry. And then the third one is enhanced performance. So you already have an algorithm that can be applied to a problem. You have quantum advantage, but maybe it takes 2,000 logical qubits to do that. So if you could have, instead of 2,000, only 100 logical qubits, that would be amazing, right? If you could actually decrease the resources required, because then you bring this application that we know we have quantum advantage, we know we can apply to a really exciting problem that would have big impact more near term. And that's another entry. So here I just want to give you, for those who are kind of in the field, and have heard about algorithms and developments, right? I just want to give some examples where kind of like novel algorithms, like the different categories that there was just novel algorithms, new application, resource reduction. So kind of give you an example for this. So here's like a paper for novel algorithms, for example. There was a paper published by Matt Hastings. That's just an example, right? So if you look at this algorithm, for example, it achieves a quadratic quantum speedup for tensor principal component analysis, right? It's a novel new algorithm, right? But for the XPRIZE competition, it was really compelling, right? If you then can, for example, can apply this actually for a very specific real-world application and provide estimates for quantum resources needed to achieve a practical quantum advantage, right? So that's kind of like the idea, like where you develop a novel algorithm with a quadratic speedup or like exponential speed up, which is very difficult to do. And then you have a very small, maybe space where you get this quantum advantage, but then you have to map a real world problem into that space where you can get quantum advantage. And that's like what we're looking for in the prize. Another example here is for a new application. For example, you can look at this paper here, for example, quantum algorithms for simulating the wave equation. The wave equation, has so many applications, right? It's kind of like using quantum linear system solvers or Hamiltonian simulations, right, to give you this superquadratic speed up, simulating classical waves, right? Or coupled harmonic systems. So I'm a trained physicist, especially in biology. We model a lot. And we should do biophysics with like coupled oscillators, right? So it's wave equations coupled oscillators. It's just a very good tool, has a very broad application, right? But you kind of like, for this specific paper, if we would look at this, like we would say like, okay, now we need to kind of estimate the resources for quantum advantage in a real world application, right? So that's kind of like what you would be looking for. And the last kind of like closing the loop here, enhanced performance. So I gave you a little bit of an example regarding simulations for chemical molecules. Here's an example of the nitrogen fixation catalyst, FIMOCO. And obviously this has been researched and studied, and over 2,000 logical qubits, like I think 10 to the 10 to Foley gates, should take about four days to compute on a superconducting device, right? But obviously you would like to bring this more near term, a larger resource reduction. If you can reduce the resources, right, to something that a quantum computer can handle more near term, this would be really big improvement. So this is what we're looking for in the competition. So kind of the judges are looking for, how near term something is. So the project magnitude, the positive real world impact, estimated quantum resources required for quantum advantage. So how near term, how strong is your evidence, right? And kind of like novelty of your approach. Is there like a new thought delta introduced? And we have 17 judges on our board. We are continuing like, getting new people impaneled. So in any case, it's kind of like a very exciting time to see what comes out. So now I just want to give you a little bit of an update regarding where is the competition, right? We have been running it for a year. What is the outcome? What are you going to hopefully look forward to? So we are in phase 1 right now, which is going to be ending at the end of this year. December this year, phase 1 is going to be over. And at the end of this year, we're going to have up to 20 finalists that will split this $1 million equally. So up to 20 teams will split this $1 million equally at the end of December. So look forward. And then these finalist teams will move forward to phase 2, which runs another year. And then in March 2027, the winner is going to be announced, where then runners up will split $1 million, and then the winner, maybe one winner or up to 3 winners, will then have like $3 million prize purse to either take for their own or to split. So this is kind of the prize purse. Why this prize purse? So it's a paper-based competition, meaning that you have to do like a thorough proof for your quantum advantage for a given like problem, right? But you don't have to run it on a quantum computer yet. So you could use fault-tolerant quantum computing and so on. Is one place I've seen November. Yeah, so the phase 1 submission is now August 1st. So we have like made that probably. So when we started the competition, we had an open feedback period. And the feedback was that the phase 1 was, so phase 2 was too short. So we have kind of like extended phase 2 and then have shortened phase 1. So everyone is in the same competition here. And we made that announcement, I think, back in July, that now in August is going to be the submission. I do get a couple of questions here. Okay, cool. So right now, where we are, we had the phase 1 interim report due, so this is why I can speak to you about the ecosystem a little bit, so what you should be looking forward to. And then the wildcard registration will open in May 2025, so next month, where we're still going to let teams in to join the competition, but the judges will judge if your proposal can actually be competitive. And then phase 1 submission is going to be August 1st, and then we're going to have judging the rest of the year, and then the phase 1 finalists will be announced in December. And then you have 1 year to do the phase 2 submissions. So judges will give the finalist teams some feedback regarding what they should be working on, what they would like to see improved. And they're going to do then an impact analysis of their algorithm on a real world problem. And like, for example, how much, like how near term, like what problem would it solve? What's the impact of the problem to the people that maybe like suffer with this condition? And then also like capital wise, right? How much can you save in an investment, right? Or like what you need to like come up with in order to solve the problem, or in order to develop drugs, right? Like how much can you reduce the resources, capital needed in order to like solve the problem based on your algorithm. So you're going to do an impact analysis, the teams that are in phase 2. And then we're going to have the winner announcement. So now we're going to go a little bit, give you an idea about what's in there in the competition right now, and to get you excited, hopefully. So I initially told you that we had 750 teams from 70 some countries initially interested. Now, after the interim report submission, there are currently 220 teams from 39 countries. And here you kind of like see like the ecosystem. You may expect that US and Europe is indeed like very well represented. But we also have, teams from other regions, which are very excited about. So it seems to be a diverse field of competitors, which is very exciting because we do believe that being diverse and coming from different areas and from different, backgrounds is really going to help you, come up with these great solutions that we need to have. So then contribution types. So I told you that we're looking at different contribution types, right? So one of them is noble algorithms. So it turns out that almost half of the current competitors feel like they're going to come up with a new algorithm. That's just amazing. We're very excited to see this. We are just hopeful that, this competition indeed will have new algorithm development. New applications is next with about, the 35%, and then enhanced performance is like around 18%. So enhanced performance is this again, where you kind of like keep chipping away, make something more near term as you move forward. So next one maybe is interesting to the ecosystem because, you hear a lot about, some, the ecosystem saying, okay, if you have quantum advantage, it's going to be with this machine. Or others saying, we are already having useful quantum computing. So I just want to give you here like an idea. Obviously, some teams have selected multiple quantum architectures. They're going to hopefully propose that their quantum algorithm is going to be run on. But kind of like the largest chunk right now is hybrid quantum classical computing architecture. So that's interesting. Then obviously NISQ is also a very large piece of this pie, which I personally was interested about because, NISQ is kind of like where people say, there's no quantum advantage. It's very, skeptical people say there's no quantum advantage. So it's very interesting to see that people are still, marching ahead and trying to find areas of quantum advantage for really tough problems we have with NISQ devices. Obviously, fault-tolerant quantum computing, I think that may have been expected. Adiabatic quantum computing and quantum annealing is very well represented as well. And then you have continuous variable quantum computing, analog simulators, and others. So this kind of shows you the ecosystem right now in the competition. Very exciting. I think it's just amazing to see how much effort goes into this and, ideas. Then kind of like the abstract problem classes, give you an idea there. Maybe not surprising, a lot of focus is on optimization. So a lot of teams are trying to work on algorithms for optimization and machine learning. And that's personally interesting with machine learning because machine learning is kind of hard to prove, right? You have to do quantum machine learning, right? With kind of like like, you have to anticipate the data you're going to work with, right? And you also have to anticipate the hardware you're going to work with. So it's definitely very challenging to develop quantum machine learning, because at the moment, when you test these systems, they're still very small. And it's just exciting to see that there's so many of the competitors that want to like tackle that, kind of like how you balance where we are right now, where we want to go. Quantum simulations, I think that was kind of also a kind of expected area. Differential equations, that has a very wide problem space. Cryptography is exciting, interesting to see quantum communications. So we also have some areas of applications that maybe are interesting to see, like what they're moving forward in with quantum algorithm development. And then last but not least, I want to talk about societal challenges. So that maybe it's exciting in itself, but also maybe like still kind of like shows us that we are actually still searching for this application space for quantum algorithms. The fact that everything is listed here, from energy optimization, efficiency, drug discovery, public health, well-being, climate change, mitigation, adoption, logistics, supply chain optimization, material design, clean energy production, disease detection, prevention, prediction, I should say, climate modeling, disaster relief, nature conservation, food security, clean water, right? These are all very big societal challenges that we really need to solve. So we still like kind of like are like have this hope, like have this like drive that we can actually apply quantum applications to these fields and actually solve these challenges. So the competitor field is very diverse. I think that's what I want to tell you here right now. Very excited and hopeful that we will bring up new quantum algorithms with quantum advantage, or we bring something that we already know is great, more near term, and have like a impact sooner than anticipated. So that being said, I'm done with my presentation. So phase one wildcard window opens in May 2025. So you can visit the website at xprize.org/prizes/QC-apps. It's kind of like long, obviously, but maybe not very well recognizable. But you just go to xprize.org, right? And then you can go to the prizes and see there. If you go to xprize.org and you're just interested in the whole ecosystem, you can just sign up there for a newsletter as well, to see what's coming up in the different pipelines, what prices we have and such. And obviously, if you have some questions, you can email them to me. You can find me on LinkedIn, DM me, or QC apps@xprize.org. That brings you directly to our email for the competition, and we'll do all of the communications for this. So with that being said, now I'm happy to take answers. Looking forward to the discussions you have. Happy to weigh in and things I can weigh in. And yeah, that's it. And thanks for your attention. So if you have some questions, maybe just unmute yourself, or you want to write in the chat. Helen, I don't know how you normally do this here.
Can I ask you a small question?
Of
Maybe a
course.
bit general.
Mhm.
Imagine that you said by 2030 you want some big challenge there to be resolved or solved. Now, suppose that in within next 5 years, someone or a team come out with a solution to one of those biggest problems. The question is about accessibility. Is that solution belongs to team, or that solution belongs to the whole world in terms of accessibility, in terms of patents or copyrights or whatever? So
Yeah,
that's my question.
that's a good question. So the IP belongs to the team. So the teams in the competition, that's their IP. If they getting a prize purse, so they're winning part of the prize purse, they are finalist teams, for example. The requirement is that they make their observation public, so that people know that they have the solution. And then people go to them in order to like, work with them because it is their IP. It belongs to the team, but they have to make it public in a sense of like, here it is, this is what can do, and share what they can. So that's part of the competition. Nothing will go to the sponsors, like they don't have any rights to the IP. It's a team's IP, what they develop. And that's very natural with all of the other competition where we have, for example, like in a carbon capture, right? We had like 20 finalist teams. The people that received the prize purse can all scale to like thousands of, gigatons of carbon removal a year, and they got investors in, right? That's their IP, it's their technology, but they got investors in, and the ecosystem is trying to bring it down so that actually, everyone can use the technology. So there's this idea of like convening the ecosystem, getting funding in, and making things accessible over time. But obviously, there is like the given for you if everyone is going to use it. It depends on also like quantum computers, right? So like the XPRIZE has no control over, like how quantum computers will be used, like who can access it, how expensive it's going to be and such, right? It is a very hard question to answer, but we do hope that the whole ecosystem understands, for these problems, that we have to make an effort to make it accessible to everyone with a reasonable amount of, capital when we get to this point. I hope that answered your question.
Yeah, thanks. You answered my question. Thanks very much.
Hello, Dave?
Yeah. So my understanding of the IP issue is that the team would retain ownership of patents, but they would not be able to maintain trade secrets. They would be required to publish all of the details of how their technology gets implemented. Is that a correct assessment?
Yeah, I think that the algorithm, if it's an algorithm development, it would have to be, like made public regarding how the algorithm works. Does that make sense?
Right. Okay, so I was involved in a proposed post-quantum cryptography, and I talked to a patent lawyer about it. We concluded that the algorithm was not patentable.
Oh.
And for that reason, it never got published. So there are going to be circumstances where algorithms are not patentable.
Oh, that's a good point.
This could be an issue.
Yeah, thanks for pointing that out.
So in general, are you going to be requiring people to make an estimate about how many logical qubits they would need to run the algorithm, and how many cycles would be required and that sort of thing?
Yes, so if you choose fault-tolerant quantum computing to be your platform for your algorithm, then yes.
Okay, thank you.
And thanks for your interest in the competition. That's exciting.
I got a question from Cheng on YouTube. He asked, what is phase 1 wildcard window?
Oh, okay. So the wildcard, so we're gonna open up in May, mid-May. It's just more like a technical thing right now. We have to in our operational platform where you go in, like we have to launch that kind of like whole way of applying. And then I think we decided kind of like mid-July, it's gonna be the window is gonna be open. So you can submit an interim report. You can just reach out to us. We can give you the details. You can get ready for it already. And then the judges will look at your submission, and then you are ready for phase 1. But if you really want to come in through the phase 1 wildcard, you kind of already have to start developing your phase 1 submission too, because phase 1 submission is going to be due August 1st. So if you are waiting till July to enter the competition, you may only have a month to develop your solution. So we would advise you to already start developing your solution. And, hopeful, if it's, clicking the check boxes, it's likely that you get, after review, admitted to join a competition. But overall, like whatever you work on should never be lost, right? Ideally, you want to publish and share with the community, or it should help you develop something in any case. So we're hoping people join a competition because they're working on things like this already. But yeah, mid-May to kind of like mid-July, probably. William, yeah?
Fascinating presentation. I really loved it, and been a
you.
big fan of the XPRIZE for many years. So thank you for explaining in detail how it worked. I really appreciate it. My question is about objectivity. I understand you have 17 fully credentialed, experienced professionals, but once we get into politics, even here in the United States. Which state thinks they're the most important, or how people get to the Olympics or whatever. How do you ensure that the results of the competition are more based on objectivity and not politics or favoritism?
Yes, yes. This is a very very like important point you're making, and this discussion we have with our judging chair a lot now, our judges. So Ryan Babush, School of Quantum AI is a judging chair of the panel. And we are very open, the panel is very open to ideas that are, if it's very well proven and you show the mathematical rigors, they're going to be open to anything. We have to be open to anything. We can't be political here, and the judges understand that, because we as an ecosystem need something that moves us forward, and especially we make all these claims. We're making all these claims, right? And it's still kind of like, yes, theoretically we can, but when you implement it might be others, right? You have these resources, overhead, you name it, right? Depending on what modality you work on. So it's in our best interest an ecosystem to actually prove what we are doing. It's kind of like, I feel like XPRIZE sometimes is a smell test, right? We have in the past not given out XPRIZes, so 10% of the XPRIZes we're not giving out. Are we too audacious with this, what we're asking, right? Is what we definitely don't want to give out an XPRIZE word. The ecosystem doesn't feel like it is an XPRIZE and it has solved what we were looking forward to. So I'm very confident that this is understood for the panel of judges, that we want to be very open. If there's proof, that's what we're looking for. And because we want to move forward the ecosystem with the promises we have made. That makes sense? Hopefully.
Another question, if I may,
Mhm.
is regarding the verification of the solution. Suppose a team claim that they have achieved the goal. Now, how will you verify that? Will you have independent teams to verify the solution? And also the question about the machine dependency, the hardware. Is the solutions have to be generic, applicable to any kind of quantum machines, or has to be acceptable for particular types of machines?
Yes, thanks. So I want to clarify that again. It doesn't have to be particular to any, it doesn't have to be general. It can be any kind of modality you pick, right? It could be fault tolerant, NISQ, annealers, whatever you want, you can pick. It doesn't have to be general. That being said, so is it going to be tested? So this is one, obviously, again, XPRIZes haven't been given out in the past. So I'm not saying that this is going to be one of them, but I just want to say that there has to be the proof has to be very clear that you, for example, make it into phase 2 of the competition. In phase 2 of the competition, depending on what the finalists are working on, it could potentially happen that there might be algorithms that actually could be run on hardware, right? It could happen. It's always not the initial goal of the competition that you have to run it on hardware, but it could, especially if you make a claim that you have classical advantage over classical compute. There's going to have to be some thorough, investigation. So in phase 2, we are hoping, after we have kind of narrowed the competitive field and see our finalist teams that come in with very compelling ideas, right, that already have a very good foundational proof, that at least from the ecosystem, from different experts, is seen as something that is viable potentially. In phase 2, you're going to have to dig in and exactly what you say, so that the prize still has to kind of figure out then, by narrowing it a little bit, depending on the finalists, what exactly will that look like, what you just pointed out, that, we're going to have to somehow benchmark it, run it, see actually if it's really has this impact that they claim, or teams claim to have. So yeah, so there's more to be done in phase 2 of the competition.
Yeah,
So
thank you.
potentially annealing, right? It could run on hardware because annealers already have thousands of qubits.
Thanks a lot.
Aaron has a question on YouTube. Does a team having an existing patent or patent pending help with the scoring or increase the chances?
No, we're not looking into that part. You don't have to submit your patent or pending patent. Like it's but you have to submit your like a phase 1 submission with all of the proof for the judges to judge your entry. But it's not gonna be like extra. What we are tracking with the patents, it's kind of like the whole ecosystem, right? When you started of the competition ecosystem, like how many like new ideas that you have, and then how many new ideas that you add through at the competition. So that's what we're looking for with kind of like the number of patents, because we're interested in that. But it's not gonna necessarily, like the number of patents, we're not gonna like boost your the way judges look at your your entry. It's really the technical stuff in your entry. Does that make sense? Anyone else?
Questions?
Hi, is there any list of problems I can read that you're working on?
So so we are like what I shared right now is kind of like the high level kind of like of the ecosystem, what they're working on. But we are not publishing any lists at the moment of the problems. Our teams are still working on their ideas. Like you are more than welcome to like sign onto the XPRIZE competition website. Once you make an account for the competition website, you can see which teams are in the competition and what they shared out, what they're working on. Some teams are open and say that they're in a competition. Some have published potentially what they're really working on, partially of it. So any case, like we are not like publishing a list, but once we announce the semifinalists, which is going to be the up to 40, which we're going to like November-ish, probably, before they get further selected to the top 20. So the semifinalists, that list of like the top, kind of like up to the top 40 ideas and what they're working on, that will be published sometime in November.
Okay.
And I noticed there's a question from Louis. What will happen if an AI came up with a new algorithm?
Oh, I don't know. The judges will have to judge this. Yeah, I don't know. We have not made policy or like kind of like AI specific entry arrangement for the competition. Possibly because we hope it's gonna AI might accelerate and like figuring out the algorithm, but I don't know. We'll see.
If I could make a comment, if that actually happens, I'm not saying this as a joke. If that happens, you must seriously look whether it was stolen. And I'm in no way exaggerating.
Oh, I see.
An AI algorithm based on large language models cannot possibly solve that kind of a problem. If you watch what's going on there, if that happens, is you have theft. And I could go in all sorts of details, but at least beware.
Okay, thanks. Yes, William?
For your reference and also for the group's reference, I posted a report that came out a couple of weeks ago. It's about the state of the quantum industry, and there's a lot of good facts in there that you may want to use for future presentations.
Thank you.
Sure.
Can you share? Did you share it in the?
Yeah, it's shared in the chat.
Okay, cool. Thank you.
Sure.
For a good okay, so that's what you okay, cool. Any other questions from the audience or online? Or...
My apologies for missing out on most of it. I had a minor medical issue with my granddaughter.
I hope everything is okay. Thank you too, William. Really enjoyed the conversation. It's good to be, in an ecosystem where you have different opinions, you have different backgrounds, different expertise. This is one thing that I kind of like hope we're doing better in a quantum ecosystem. We are kind of sometimes in a bubble and think we can solve everything, but not necessarily without talking to other experts. So that's part of the XPRIZE as well, making sure that we're connecting with the right people. So thank you for all your interest. I'm really excited to see this kind of engagement. Thank you. Yes, XPRIZE is a great project. I've been enjoying my year in the foundation. It's very, the work itself is very lifting. It's kind of like very inspiring and kind of like it gives you hope and so many dreams people have, and then they go and they march along in an XPRIZE, and then they can just achieve these audacious goals that we set forward like years before, 4 or 5 years when we design a prize, and then suddenly they unlock it that we initially thought was not unlockable anytime soon. So it's a very fulfilling kind of like adventure I've been joining the last year. Thank you so much for all your support and kind words here. Appreciate it.
Yes, thank you.
I had a quick question on this may be trivial, but does the finalist and the winner, do they also get to go to Santa Barbara to the Google Quantum AI facility? Is that part of the
I don't know what the sponsors maybe do. Unclear. I can ask them if that would be something they would like to sponsor in addition. So at the moment there are no plans, but I could float the idea, of course.
Thank you.
Oh, thanks, George.
Any more questions? Oh, I see. Question. Is number factoring a social issue? What would number factor be articulated as to solve social issues? I was having trouble framing it in this way and choosing a category. Let me post a question on the chat.
Okay, thank
It's
you.
from Aaron on YouTube.
Okay, thank you, Aaron.
The question is number
Factoring a societal issue? How would number factoring be articulated as to solve a societal issue? I was having trouble framing it in this way and choosing a category. That is obviously like a very good, that's exactly what the prize is about. So you have number factoring, right? We know you have this quantum speed up. How do you now apply it to a societal issue? And how do you like map it? That's I totally understand. Like this is something that teams have to figure out. Unfortunately, I can't really help with this because if I would know, I would maybe be in a competition myself. But possibly, there are like maybe ideas of around, the technology, like maybe as like a being something within another technology, right? Maybe there's some factoring, number factoring that is part of some other piece that then can be connected to societal problems. Maybe that helps you. Maybe there's no direct connection of factoring to societal problems, possibly, but it might be plugged into another kind of like set of tools that works together, and then it could possibly be applied. So there's different ways maybe you could look at that.
Hypothetical case, or hypothetical situation. Imagine that within that timeline for someone to come out with a solution, no one comes with a solution at all, or the solutions are not good enough. Will you extend the deadline or repricing again for the coming years?
That's a good question. So I'm very optimistic that we're gonna have finalist teams moving forward to phase 2. So that's gonna happen, and there's gonna be part of the prize purse is gonna be given out. So $1 million of the $5 million will be given out. Then if there's indeed no grand prize winner, right? If there's no winner of the competition, the judges will make that call. It's up to the judges. And then once there isn't made a decision that no one did what we were set out for, it was still too audacious for the ecosystem. It could be twofold, right? It could say like, okay, maybe we're kind of like stuck right now. We still need to work harder, or it was just too audacious. Maybe we were dreaming too much a little bit. But in any case, then the sponsors will have the choice of what to do with the remaining prize purse. I would not think it's going to be extended, but potentially there could be another follow-up prize when the time is better. But yeah, so the sponsors will have to make the decision what they're going to do with the remaining prize purse if no winner is announced.
Thank you.
Yeah, William?
Yeah, this is said in jest, but also it's possibly kind of serious. I mean, like not just at the rate things are going in the world geopolitically and the economy and stuff, you may want to put a caveat in there that you reserve the right to change the national currency denomination of the prize. You may want to reserve the right to put it in euro or some other denomination, because some of us aren't so sure about the dollar anymore.
Oh, that being said, like if you look at the guidelines of the like not necessarily you know, like expecting that, I'm just saying like I'm not gonna like tell like say yes we're gonna change the currency or something like this, but I'm just saying like the guidelines for the competition are written that way that we can make adjustments if need be. If something unforeseen is coming, we have the ability to make adjustments to something like that, for example.
Are there more questions? Feel free to discuss.
We may extend an invitation from the QSecDef group that's operated by Anna Headgard. She's our CEO, but we meet every Tuesday, so I may get them to contact you to give the same presentation to our group.
Oh, okay, thanks. Happy to spread the word about XPRIZE and what we try to achieve. But again, we can do nothing, achieve nothing without the ecosystem. So we need all of your help. We're really dependent on all of you. So we're good at finding sponsors for hard solving problems. So
So any more questions from the participants? Oh, another question from Juan. Any Latin Caribbean team members connect right now looking for a member? I would like to join one.
yes. So so please email me Again, maybe I should just put my email in there. How about that? So my email. Let's put my email in. So please reach out. Yeah, I hope that's the right email. Catherine. So please reach out. So we can give you the instructions how to do that. So what you do is you go onto our ecosystem, our like competitor ecosystem. It's called POP, XPRIZE.org. You make an account, and then you can actually like search for the current teams in the competition for the XPRIZE Quantum Application competition. You can search any team being in any of the active competitions right now. And then you can reach out and say like, oh, I would like to learn more about what you're doing. These are my expertise. We're going to move forward. So actually, this is very great that you're saying this, because the Indem report, when we had the submissions from them, some teams are still looking for team members. So please reach out to me. I will connect you to our team's relations manager, Brock Denton, and then we could maybe facilitate something for teams that actually look for team members, or you can actively reach out to teams in our system to see if they are interested in having you join. You're welcome.
So do you guys have more questions or more discussions? Feel free to ask. We still have plenty of time, yeah. If not, thank you for coming, and you can reach out to Dr. Spendia from her email for follow-up questions. So next week we'll have another talk from Dr. Zaki on May 3rd at noon. Oh, one more question from Aaron. What about the reverse? Teams looking for expertise, how to advertise that?
Yeah, reverse do the same thing. That please reach out to us. Brock Denton is gonna be working on the reverse as well, like how we're gonna facilitate that. But it would be good to have like collect the ideas and interest, so we know how to facilitate that the best way. So also please reach out for the reverse case.
Yeah.
I'll ask a selfish question. What's the single most important thing I missed while I was gone?
I don't know. I think one highlight was that we had just the XPRIZE carbon capture prize announced earlier this week, and the team successfully showed that they can scale to 1,000 gigatons of carbon removal a year.
That was very impressive, by the way.
Very impressive, and the winners took away $50 million.
Yeah, that was very cool. Both the incentive and the fact that they were able to do that is.
Yeah. And what I said is, like, when we started the prize, no one thought 5-6 years ago this is going to be a thing, carbon removal. It started with XPRIZE.
Yeah, there's so many things that are just flatly thought to be impossible turned out to be possible.
Correct. Just because we needed everyone to just put the teeth in and go for it.
Prizes like yours are so valuable for incentivizing that. It's just great. I work more with individual researchers, but giving them unfettered license to do some research, you could just get such extraordinary results sometimes. So getting that incentive in there for people to say, hey, I can do this, that makes all the difference in the world.
Yes. When it works out, it's a beautiful outcome.
Yeah.
Aaron has a comment on YouTube conversation. Biggest takeaway articulate how your algorithm will scale and what resources you need to scale it. Make that clear for the judges.
Yeah, thanks. Yes, yeah, that's a good one. That's definitely a good one, yes.
So do you have more questions? Do you have more questions? If not, thank you for coming. And if you have more questions, please ask Dr. Spendia for the follow-up. Thank you.
Thank you, everyone. Appreciate your time on the weekend. Bye-bye.
Sure.
Please reach out. Please
See
stay
you.
connected. Bye. Thank you.
Thank
Bye.
Bye-bye.